If the absolute value of x equals 7, what are our possible values of x? What could x be if the absolute value of that number is equal to 7? 7 and negative 7. Okay? We have two possibilities. If x is positive 7, then the absolute value of that is positive 7. If x is negative 7, the absolute value of negative 7 is positive 7. All right? If the absolute value of x is equal to negative 4, what are the possible values of x? Is the absolute value of 4 equal to negative 4? No. Okay? There are none. There are none on this one. A little bit of it, I don't want to say trick question. It's not a trick question, but it's trying to get you to think here, okay? You got to shift your mind from what we just answered in number 1 to think about number 2 here. The absolute value can never be negative, okay? Absolute value can never be negative. Now, your answer over here can be negative, but the absolute value will never give you a negative number, all right? So, here's some steps to solving our absolute value equations. Number 1 thing that you have to do is you have to isolate your absolute value expression. Now, in these first couple of examples that you see down here, you don't have to do that. It's already by itself. But then we'll look at some examples here in a minute where you do have to do something to get that absolute value expression by itself. Then, after we've isolated it, we create two cases. We split it into two. We set the inside, and what I mean by the inside is what's inside the absolute value bars. We set that equal to both the positive and negative value of the other side. Okay, so we're going to have two cases, set it equal to the positive and to the negative of the value that's on the other side. We're going to solve both of them, and then we're always going to check our solutions. Number 1, because there's no reason why we should never check our solution to an equation. You can catch a lot of careless mistakes if you take just a quick second to plug your answer back in. But the second reason why we want to check our solutions is because sometimes we can end up with what we call an extraneous solution. An extraneous solution is a solution that is found when solving but does not actually work. Extraneous solutions, you've never really had to deal with that before, with linear equations, with quadratic equations. If you get an answer, it's the answer, unless it's, just the wrong answer. But as long as you get a correct answer, you don't make any mistakes in your work, the answers that you get always work out in the equation. But because of cases like number 2, you may get some answers that, when you work it out using this process, you get it as an answer, but it doesn't actually give you a valid solution. So extraneous solutions are something kind of new. They'll come up with absolute value equations. Sometimes they come up with radical square root equations. And then later on this semester, we'll look at rational equations. And sometimes there are some extraneous solutions with those as well. All right, so just don't be thrown off by that word, extraneous, the root of that extra. Okay, you get it as a solution, but it doesn't actually work out. Okay? All right. Just trying to give you all plenty of time to write that down. So, like I was saying, these first two examples, step number 1 doesn't apply. Okay, it does not apply. We don't have to isolate these absolute value expressions. They are already isolated. So we just skip to step number 2. Create two cases. I like to do this whenever I'm at to the point where my absolute value is by itself. I like to draw two lines from it just to remind myself Don't forget that second case. All right, don't forget I've got another problem that I have to solve. So for the first one, you just keep everything the same. The absolute value bars are just gone. Okay, keep everything the same. You just drop those absolute value bars. For the second case, you keep everything the same except that number that was on the other side of the equal sign, you change its sign. So in this case, it becomes negative. And then usually you have very simple equations to solve. These are linear equations, most of them one step. So we add 9 both sides, so we get 14 for one of our solutions. We also add 9 in the other equation, but we're adding 9 to -5, so we get +4. Before, most of you probably box in your answers, I do too, but before I box it in on things like this, I always check it. Plug it back in. 14 minus 9 is 5, absolute value of 5 is 5. 4 minus 9 is -5, absolute value of -5 is +5. Both of them check out, so then I'm going to box my answer. It's just an extra little precaution to make sure you do what you need to do for checking. All right, let's do another one like that. Again, absolute value already isolated, so I'm just going to create my 2 cases. This one flips sides with where the absolute value is. It doesn't matter, same thing, okay? I'm only going to change the sign of the number that was not inside the absolute value, or that's on the other side from the absolute value. All right, this one, still a linear equation, just a couple more steps to solve though. Subtract 7, so we get -4 is equal to 2k, divide by 2, so -2 is equal to k. Same steps on the other side, we're just going to get different numbers. Subtract 7, so -3 minus 7 is -10, divide by 2, -5 is equal to k. Now again, don't freak out because you have negative answers. Negative answers are possible. What's not possible is your absolute value equaling a negative number. All right, so plug them in. 2 times -2 is -4. -4 plus 7 is 3. So we're good on that one. 2 times -5 is -10. -10 plus 7 is -3, but we take the absolute value of it, so we get +3. So both of those check out. All right, simple, right? Let's look at somewhere we have to isolate. Okay. Example number 5. Or it's numbered number 5. It's not the 5th one we've done. Okay, notice this time the absolute value is not by itself. So our first step is we've got to get it by itself. So we subtract the 17 from both sides. So now we're looking at the absolute value of y minus 1 is equal to 6. Just so you know, you never, ever, ever change what's inside your absolute value. Ever. You never change what's inside the absolute value. Okay? You leave that until you split it into the 2 cases. Another precaution, I know not everybody has the neatest handwriting, but I really try and exaggerate my absolute value bars so that I don't look at that and think that that's supposed to be an 11. Trust me, I've seen it happen. So just make sure that you know what's an absolute value bar and what's a number 1, okay? All right, absolute values by itself now. 2 cases, y minus 1 is equal to 6, y minus 1 is equal to -6. Add the 1, so we get 7. Add the 1, so we get -5. Check our solutions. 7 minus 1 is 6. Absolute value of that is 6. 6 plus 17 is 23. -5 minus 1 is -6. Absolute value of that is +6. So 6 plus 17 is 23. So both of those check out. How do we isolate the absolute value in number 6? Divide by 3. Okay, good. Divide both sides by 3 because we're multiplying by 3. And again, you never change what's inside the absolute value. Those absolute value bars are not parentheses. You cannot distribute into an absolute value expression. So you have to divide to get rid of that 3. So 39 divided by 3 is 13. Now we are isolated 2 cases. Subtract 8. And guys, you don't have to write out the minus and plus steps unless you want. I know some people are just more comfortable doing that every time, and that's why I do it. I do not require you to necessarily write out every single step. Now, if you don't write out the step and something funky happens and it messes up your answer, it's kind of hard for me to check your work and give you partial credit, so keep that in mind as well. But I just want to let you know, I don't make you write down every single step, all right? But it's kind of at your own risk. Plug it in. 5 plus 8, 13. 3 times 13, 39. Plug in negative 21. You get negative 13, but you take the absolute value, so we're in the same boat. And you can certainly check these using the calculator. I just try and keep my arithmetic skills on par, so I try and do as much of it mentally as I can. Probably a good habit for you to be in as well. Just a suggestion. All right, number 11. Number 11. This is one that I definitely want to look at because people are so tempted on this problem that their first step is that they do 9 minus 4 and they get 5. You can't do it because this 4 is being multiplied by